Well, hello there. Here we go. We are going to start this next section. Okay. It's going to be all about virtualization. So I'm going to dig right in because, first of all, we need to figure out what is virtualization. So typically, virtualization means the creation of a virtual rather than actual or physical version of something, such as an operating system, an OS, a server, a storage device, or network resources. Virtualization uses software that simulates hardware functionality to create a virtual system. This practice allows IT organizations to operate multiple operating systems, more than one virtual system, and various applications, all on a single server. Naturally, there are all kinds of benefits of virtualization, including greater efficiency as well as economies of scale. OS virtualization is going to be the use of software to allow a piece of hardware to run multiple operating system images at the same time. The technology got its start on mainframes decades ago, really, allowing administrators to avoid wasting expensive processing power. Let's have a look and see how it works. So visualization describes this technology in which an application, guest OS, or data storage is abstracted away from the true underlying hardware or even software. A key use of virtualization technology is server virtualization, which uses a software layer called a hypervisor, and this will emulate the underlying hardware. This often includes the CPU's memory, input-output, the I/O, and network traffic. Hypervisors take the physical resources and separate them so they can be utilized by the virtual environment. They'll sit on top of an OS, or they can be directly installed onto the hardware. The latter is pretty much how most enterprises virtualize their systems. The Zen Supervisor is an open-source software program, and it's actually responsible for managing the low-level interactions that occur between virtual machines, the VMs, and the physical hardware. So in other words, the Zen hypervisor enables the simultaneous creation, execution, and management of various virtual machines in one physical environment. So with the help of the hypervisor, the guest OS, normally interacting with true hardware, is now doing so with a software emulation of that hardware. Often, the guest OS has no idea it's on virtualized hardware. Now, while the performance of this virtual system is not exactly equal to the performance of an operating system running on true hardware, the concept of virtualization works because most guest operating systems and applications don't even need the full power of the underlying hardware. So this allows for greater flexibility, control, isolation by removing the dependency on a given hardware platform. While initially meant for server virtualization, the concept of virtualization has spread to applications, networks, data, desktops even. So let's go through some of the steps of the virtualization process. First up, hypervisors will detach the physical resources from their physical environments. Resources are taken, then divided, as needed, from the physical environment to the various virtual environments. System users work with and perform computations within the virtual environment. Once a virtual environment is up and running, a user or program can send an instruction that requires extra resources from the physical environment, and in response, the hypervisor relays a message to the physical system and stores the changes. So this process will happen at almost at native speed. The virtual environment is often referred to as a guest machine or virtual machine. The VM actually acts like a single data file that can be transferred from one computer to another and opened on both. It's expected to perform the same way on every single computer. Now, there are a few different types. You probably know a little bit about virtualization if you've ever divided your hard drive into different partitions. Yeah, a partition is the logical division of a hard disk drive to create, in effect, two separate hard drives. Indeed, there are 6 areas of IT where virtualization is making some headway. Network virtualization. So this is that method of combining the available resources in a network by splitting up the available bandwidth into channels, each of which is independent from the others and can be assigned or reassigned to a particular server or device, get this, in real time. See, the idea is that virtualization disguises the true complexity of the network by separating it into manageable parts, much like your partitioned hard drive makes it easier to manage your files. There's another one we call storage virtualization, and this is the pooling of physical storage from multiple network storage devices into what appears to be a single storage device that's managed from a central console. Storage virtualization is commonly used in storage area networks. So we've got server virtualization, right? This is the masking of server resources, including the number and identity of individual physical servers, processes, and their accompanying operating systems from the server users, right? Separation's always the key. Now, the intention here is to spare the user from having to understand and manage complicated details of server resources while increasing resource sharing and utilization and maintaining the capacity to expand later. Now, the layer of software that enables this abstraction is often referred to as the hypervisor. The most common hypervisor, type 1, is designed to sit directly on bare metal and provide the ability to virtualize a hardware platform for use by the virtual machines. KVM virtualization is a Linux kernel-based virtualization hypervisor that provides type 1 virtualization benefits, just like other hypervisors, but KVM is licensed under open source. Now, a type 2 hypervisor requires a host operating system and is more often used for testing in labs. Data virtualization is abstracting the traditional technical details of data and data management, such as location, performance, or format, in favor of broader access and more resiliency tied to business needs. Desktop virtualization is virtualizing a workstation load rather than a service. So this allows the user to access the desktop remotely, typically using a thin client at the desk. Since the workstation is essentially running in a data center server, access to it can be both more secure and portable. The operating system license does still need to be accounted for, as well as the infrastructure, BT dubs. Now, what about application virtualization? This is what I'm talking about. The abstraction of the application layer away from the operating system. See, this way the application can run in an encapsulated form without being dependent on the operating system underneath. This can allow a Windows application to run on Linux and vice versa, in addition to adding a level of isolation. See, so virtualization can be viewed as a part of an overall trend in enterprise IT that includes autonomic computing, a scenario in which the IT environment will be able to manage itself. Don't get too excited. Based on perceived activity. See, so it's all about perception. We'll get to that later. And there's also utility computing, in which computer processing power is seen as a utility that clients can pay for only as needed. See, the usual or typical goal of virtualization is to centralize administrative tasks while improving scalability as well as workloads. Don't worry, your future is secure. As secure as any other future is. Okay, so let's talk advantages. The advantages of utilizing a virtualized environment would include a few of these. Lower cost, as virtualization reduces the amount of hardware servers necessary within a company and data center, so it lowers the overall cost of buying and maintaining large amounts of hardware. Easier disaster recovery. Talking about the future, disaster recovery is just very simple in a virtualized environment. Regular snapshots provide up-to-date data, allowing virtual machines to be feasibly back up and recovered Even in an emergency, a virtual machine can be migrated to a new location within minutes. Easier testing. Testing is far less complicated in a virtual environment. Even if a large mistake is made, the test does not need to stop and go back to the very beginning. It can simply return to the previous snapshot and proceed with the test. Quicker backups. So backups can be taken of both the virtual server and the virtual machine. Automatic snapshots are taken throughout the day to guarantee that all data is up to date. Now, furthermore, the virtual machines can be easily migrated between each other and efficiently redeployed. Improve productivity. Now, if you're doubting this, I'll tell you. Fewer physical resources result in less time spent managing and maintaining the servers. Tasks that can take days or weeks in a physical environment can be done in minutes. This allows staff members to spend the majority of their time on more productive tasks, such as raising revenue, fostering business initiatives. You know what you do with your time. Now, of course, virtualization provides companies with the benefit of maximizing their output. Additional benefit for both businesses and data centers could include some of these. Single-minded servers. Virtualization provides a cost-effective way to separate email, database, and web servers, creating a more comprehensive and dependable system. Expedited deployment and redeployment. So when a physical server crashes, the backup server may not always be ready or up to date, so don't get caught out. There also may not be an image or clone of the server available. So if that's the case, then the redeployment process can be time-consuming and tedious. However, if the data center is virtualized, then the process is quick and fairly simple. Virtual backup tools can expedite the process in minutes. Reduced heat and improved energy savings. Now, companies use a lot of hardware servers risk overheating their physical resources. And the best way to prevent this from happening is to decrease the number of servers used for data management. The best way to do this is through virtualization. You thought we were going to talk about air conditioning, didn't you? Now we will. It's better for the environment. Simply put, companies and data centers that utilize copious amounts of hardware leave a really large carbon footprint. They must take responsibility for the pollution they are generating. Virtualization can help reduce these effects by significantly decreasing the necessary amounts of cooling and power, thus helping clean the air and the atmosphere. As a result, companies and data centers that virtualize will improve their reputation while also enhancing the quality of their relationship with customers and the planet. There's an easier migration into the cloud. Virtualization brings companies closer to experiencing a completely cloud-based environment. Virtual machines may even be deployed from the data center in order to build a cloud-based infrastructure. The ability to embrace a cloud-based mindset with virtualization makes migrating to the cloud even easier. Get this: lack of vendor dependency. I realize that might be controversial, but hear me out. Virtual machines are agnostic in hardware configuration. You might have deduced that already. But as a result, virtualizing hardware and software means that a company does not need to depend on any particular vendor for these physical resources. Now, before you get so excited that you're already converting to a virtualized environment before you even finish this course, hear me out. Before you go converting into a virtualized environment, it's very important to consider the various upfront costs. Yeah, there's limitations. The necessary investment in virtualization software, as well as hardware that might be required to make that virtualization possible, can be very costly. If the existing infrastructure is more than 5 years old, an initial renewal budget will have to be considered. So fortunately, many businesses have the capacity to accommodate virtualization without spending large amounts of cash. Furthermore, the costs can be offset by collaborating with a managed service provider that provides monthly leasing or purchase options. There's also software licensing considerations that's got to be considered when you're creating a virtual environment. See, companies must ensure that they have a clear understanding of how their vendors view software use within a virtualized environment. See, it's becoming much less of a limitation as more software providers adapt to the increased use of virtualization. Converting to virtualization takes time, and it may actually come with a steep learning curve. Implementing and controlling a virtualized environment demands that each IT staff member is trained and possesses expertise in virtualization. Furthermore, some applications do not adapt well when brought into a virtual environment. The IT staff will then need to prepare to face these challenges and address any of them prior to converting. Now, there's also security risks involved with virtualization. Data is crucial to the success of a business and therefore is a common target for attacks. The chances of experiencing a data breach significantly increase while using virtualization. Now, finally, in a virtual environment, users lose control of what they can do because there are several links that must collaborate to perform the same task. You follow, right? If any party's not working, then the entire operation's going to fail. So, my friends, I hope I didn't scare you too much there, but you got to know the pros and the cons. That's all about virtualization, and now you know more than you did before. Congratulations, and we've got more for you on the other side. See you then.